All right. Let me introduce this car, please. This is a 2006 Volkswagen that was bought off of a auction, maybe, or a customer. I'm not sure, but it was bought with a broken timing belt or chain. Belt? Belt. 2.0, 2006. Did I say that? 2006 Volkswagen Passat Turbo. Yep. Bought with a broken timing belt. The owner of the vehicle said the car ran fine until the timing belt broke. So this was bought by a mechanic who put a timing belt on the car and doesn't have spark. Okay? They told me, that they being the mechanic who now owns the car, that he verified compression and he's missing spark. So we did start on this off camera. I had Shane and John, and who else was involved?
Shane and John.
Shane and John. Involved with troubleshooting this Volkswagen, and I thank you for letting me do this together with the class. I thought this would be a good time to do this because we're studying ignition systems, we're studying no spark diagnosis. This is a coil-over-plug design. The one that we did yesterday was a distributor design, and I thought that was very good for this subject matter as well. And I thought we could take this one and plug it in. I don't know where this is going to go. It might end up taking us in a completely different direction away from the ignition system, but we can at least start, because we're doing ignition systems, we can at least start with that part of this and plug that into, you know, your test that's tomorrow. Okay? And then the rest of this will be good just in general troubleshooting. How much do we want to inform them of what we did? I think we should. No reason to retrace some of it. We have no communication with the scan tool. We do have a 5-volt reference. So these are standard checks, guys, that you do for a vehicle that is not starting and in particular is not communicating with the scan tool. Is, do you have a 5-volt reference? You can have, let's be clear, you can have a communication problem and it not be related to the no start. We can have an issue with the data link cable. I've seen it many times having vehicles, especially the Euro market, where they don't communicate properly, but the car runs fine. So is our communication problem tied into our no start? We don't know yet. But what we do know, in that scenario, what you do for a no start is you check for a 5-volt reference. What does the 5-volt reference tell us about the engine computer? I don't want to say it's good yet. It's alive. It's at least powered up. That's the same thing we did on that Camaro, a 1989 Camaro. We're plugging in the same exact troubleshooting procedure into this 2006 Volkswagen, which is when we checked the Camaro, we didn't have a 5-volt reference, and that's what led us to that blown fuse for the. Actually, it was for the fuel pump circuit, but it also fed power to the ECM. That's what put us in that direction. No 5-volt ref. Powers and grounds, okay?
5-volt ref on what, okay?
5-volt ref on anything, Kendall. Remember, the 5-volt reference circuit is shared throughout the whole system. There are some systems that have multiple 5-volt reference circuits, 1 or 2, or more than 1. I've only seen 2 as the other alternative. But 5-volt reference on anything. The sensor that you guys ended up checking 5-volt reference on, to be honest with you, I don't even know what it is. It was this component right here. And it looks like that these are fuel lines down here. These silver lines, can't really see them very well on that. Well, you can kind of catch a glimpse of the shiny part down in here, this silver line. That comes up, that goes to the fuel rail, it looks like. That goes to my injectors. And those are, hang on a second. Can't tell. I just thought maybe this was a GDI system, but it doesn't look like it. I don't know what they're doing with this. This is some type of electronic fuel pressure regulator, guys. Just based on the way the fuel lines look. So if that's the case, what would this sensor be that Shane and John checked the 5-volt reference on? If this is a fuel pressure regulator, which it looks like it is, this is my fuel lines. There's a 2-wire sensor that goes right on the side.
What would that be, the temperature sensor?
Temp sensor for the fuel system. It would be a fuel temperature sensor is my guess. I'm not totally sure. When you did that 5-volt ref check, you unplugged it, correct?
No.
Or did you do it plugged in?
I don't remember.
Thanks, Dave.
For the sake of wanting to be a good student, I'm going to say we did both.
No,
Only left it plugged in.
This is important because, listen,
Plugged in.
well, that gives me a clue right off the bat if you did that plugged in. Should we ever read 5 volts on a thermistor plugged in?
It was a 3-wire sensor when I checked.
Oh, then it's not a temp sensor. Hold on a second.
Make sure.
It is a 3-wire. Okay, I feel better about that. 3-wire means that is a pressure sensor, not a temperature sensor. That is a fuel pressure sensor that you guys checked 5-volt reference on.
Okay.
Back to Kendall's question. No, we don't necessarily have to check the 5-volt ref on the crank sensor. Number one, not all crank sensors use a 5-volt ref. A lot of them use, like the vehicle speed sensor one we did as a field trip, the Dodge truck. That one used an 8-volt supply. It didn't even use the 5-volt reference circuit. There are other crank sensors that would use a 12-volt feed and a ground and then create a signal, send it to the computer. So not all crank sensors would use the 5-volt ref. But the 5-volt reference circuit in general, the point is the computer is most likely alive, having main power, main ground, and doing part of what it should be doing. Okay? What else do we know?
For sure?
Yes. We're missing spark. We verified that. Did we check injection pulse?
No, we didn't get to the injection.
Well, we'll start with the spark test, just to let you guys see that.
We have power to the coil.
We have power to the coil. We'll verify that too. And then we'll talk about the 4-pin coilover plug design and how to troubleshoot that. So that'll be our starting point. Then where this goes from there, who knows? Wait till you see the wiring on this. In fact, a lot of you haven't seen it. This is what not to do, okay? When you are back probing computer pins and connectors, the last thing that you want to do is to take a razor blade and cut the insulation away so you can put your alligator clips of your multimeter on there.
It should also be noted that everything on that vehicle engine
Yes.
came to us like that. We didn't touch
Oh, yeah, no,
anything off or do
For sure, we should show the interior of the car too, which is like this thing's really torn apart. Oh, I should get a shot of the ignition. Let's get a shot of the ignition switch. Okay, guys, listen. If you're going to do this, a small hole with a piercing tool is fine. And what are you doing when you're done?
Yeah, it'll feel it.
Where is my tape? Someone had it last. Did you give it back?
You gave it to me, but never gave it.
I gave it to you, but never gave it to you?
You were able to use this. I was like, oh, I'll use something else.
What?
Yeah.
I don't have it anymore, John. It's not there, John. It's all your fault, John. It's always your fault. It's your fault Mom and Dad got divorced. That was Zathura I was quoting. Okay, I don't have it to show you the liquid electrical tape. I bought it at Walmart for like $5. It's literally called liquid electrical tape. That I found to be very helpful, and I have heard from some of you are thinking we'll just use RTV. I'm not a chemist, so I can't answer this question, but I have heard from some that RTV that has silicone in it is corrosive to copper. So that's not the wisest choice. I have heard that. That is only what I've heard. I am not a chemist. For those of you that think I'm an expert at everything, I am not. Okay? Anyway, liquid electrical tape. Or some other recommendations was fingernail polish. The clear stuff is another good one. Here, give me that. Throw it. Where was that?
I don't know.
So you can't. Well, it doesn't really help. You can't even read the label anymore. It's made by Permatex, and it's called liquid tape.
It was out in that
It is John's fault.
Crappy.
You're a crappy Volkswagen, John.
John. Yeah. I
Yeah.
haven't touched that car.
Okay. All right. So don't do that. I can't I mean, I'll use it, but that's horrible, guys. Don't do that. Let me show you the ignition switch. This is crazy.
It's all taped up.
Oh, you taped it? I can't show it? Okay, never mind.
I had to shorten it out.
You just show how many pieces of tape you have.
I could do that. So yeah, the interior is all pulled apart. Things kind of laying everywhere. And then if you look, this is the back of the ignition switch. Every single one of these wires had the same butchered up harness. So the other thing too, when we started, I guess we should tell everyone, is, John, you just mentioned there was a fuse that was missing or blown, or we had a couple fuses. Missing? Some missing fuses.
Blown one somewhere.
Blown, missing.
Those on the ground.
Freaking tranny shop. All right, so now what? Coils, check for spark. Did you guys bolt this coil back up? Or is it just, can I just pull it out?
Yeah.
I'll just pull one of them out.
Be really strong then. Wow.
Should we leave that, or is that an edit?
No, leave it.
That was Shane. You guys know who Shane is, the one that crop dusted me on the Jeep. Yeah, that's whose voice that is. What did I do with my test light from yesterday? It's right here. All right, who's going to be my cranker?
Who's the soldier boy?
This vehicle will continue cranking, right? Like,
If you
How-
hold it,
but I mean, it's computer controlled starter, so if it's not starting, does the computer keep cranking it, or
no,
it doesn't?
If you let go,
All right, the only thing that I'm doing first, guys, is just the old school, easy spark test to see if we have it. We do not, but I'll let you see the test, which is simply taking an incandescent test light, going to ground, and
you want to check your ground?
actually I don't. That's a good question. We can check the ground, but the reason I don't care in the case of a spark is I don't need to have a good ground in a sense that I do for my 12-volt circuit when I'm measuring 60,000 volts. It'll go there even if that ground location is poor before it will go to me. As long as the metal you connect to isn't connected to a plastic intake manifold, then you should be fine. But go ahead and crank it. Okay. This engine does not sound like it has good compression. Did you hear how easily that cranked?
Maybe.
Did that sound like a compression issue to you? Let's listen to that again. Crank that. I don't know. I mean, he said compression was verified. Okay. A comment that I just cut is it is possible that this timing belt was put on incorrectly. It's also possible that the valves are bent on this engine when the belt broke. Does anyone know if this is is this an interference motor?
So you bent every valve.
Well, the compression issue that he said he verified, we're going to have to check that. But here's the thing. If the valves are bent and he put this back into time, shouldn't we still have spark?
Yes.
Okay, so shouldn't we attack this right now? Put the cranking sound aside for a minute. Because what are we learning right now? We're learning no spark troubleshooting, no start diagnosis when you have no spark. Let's walk that path and see where it takes us. Cool?
Yep.
Okay, so we have no spark, and the next step would be, well, it's different on every car. What's the next easiest thing to do? Given that the vehicle doesn't even try to start, just logically speaking, is it possible that, let me back up. Given that this vehicle does not even try to start, is there a reason for me to check the other coils for spark?
No.
No, I mean, you could if you wanted to, but I think it's a waste of time. We have one coil that's not sparking. The engine doesn't even try to start. No reason to check the rest of them. if the rest of them were working, what would we have? A single cylinder misfire. But to each his own. Me, I'm not checking all 4. So we have something in common to all of them. And I think the first thing would be that you guys understand how these coilover plug coils function. And without a wiring diagram, I think would be first. Because this is what you'll be doing in the field. When you look at one of these systems, you want to have a fundamental understanding of what they're doing and how to identify the control circuits. So how are the coils being controlled? I want you guys to see the wiring on this. All right, so we have 4 different coils. And what we look for in this case is we look for common wires. There's 2 browns on the end of that coil. There's 2 browns on the end of this coil, 2 browns here, and 2 browns here. So they're all sharing that. And then on the end is a brown with a green. If I can show you the green tracer. Brown with green on that coil. On the end is a brown and green, brown and green, brown and green. And then the 4th wire on each coil, this one looks like purple maybe. This one is blue with a white. This one's red, and this one is, don't know what, I can't see that. Some separate color. So if I want to check these coils, a coil is controlled by something, module, computer, right?
Correct.
Which one do you think the control wire is?
The one's different,
The different ones.
different colored one.
Is that something we can follow on every car?
Yeah.
Think about it. Common wires would be powers and grounds. Control wires would be individual and separate. Could we do the same thing on, say, fuel injectors on another car? Look at all the injectors and see one common wire and then different wires on the other side. That's your control wire. So without looking at a wiring diagram, could I just grab one control wire and see what the signal looks like? And I guess what you guys need is a brief coilover plug design. Let's do that first, and then I'll show you the signal. Good? Okay, so I need to switch to my desktop. And I actually have the Mitchell program pulled up. And let's do this first. I'll just draw, I guess. I'll draw on this screen. I think I can. Here's one. This would be inside of the coil. That's one of the wires. Main power, main ground. Every single coilover plug design. Okay? Every single one. You're going to have a main power. You're going to have a main ground. Sorry, let me back up. Every single 3 or 4 wire COP. Every single one will have this. The 2 wire one, the transistor is external. The 3 wire, 4 wire ones, the transistor that controls the coil is where? It's inside the coil. Okay? So remember that. Main power, main ground. What's a 3rd wire? This one right here. Where does this go? Base circuit. What's the computer doing right here?
Turning it on and off.
Turning it on and off. So is it safe to say we'll have a square wave here?
Yes.
Every single coilover plug design that's out there. 3 or 4 wire design. Okay? And what's cool about this, once you start checking these, it's pretty standard. What they're using is generally a 0 to 4 volt square wave. Some of them are higher, but that's what you're looking for. Maybe 0.12 on some. 0.5, 0.4, some type of square wave controls the base. When the transistor is turned on, what happens? What do we do with the coil? We allow current to flow through the winding. We then ground that winding. You guys see that?
Yes.
And then we're charging the field. And then when the square wave turns off, what are we doing with the transistor? turning that off, which loses the ground, which collapses the field, and that's when it sparks. Questions? Where's the fourth wire on these? This is your 3-wire one. Here's your 3rd wire right here. Where's the fourth? The 4th wire would be some tie-in here that would go to my engine computer. And this would be a confirmation. I don't know how to spell that.
Just put con.
Confirmation.
I.
I spell that right? Yay. Huh? Confirm.
Confirmation.
Is that not a no? I was happy about how I just spelled that.
I'm happy with it.
Is it an I?
No, I like it. Just the way it is.
Conform. Confirm. How do you spell confirm?
CONFIRM.
Is it? So that's an I. So I shouldn't be happy about my spelling. Either way, O or I suck at spelling, okay? On camera. There it was. 8th grade, about 8th grade, I was like, I had enough of this English crap, and I don't think I learned a thing after that. What's funny is when I was a student here, I had this person tell me, it wasn't here, but I had this person tell me while I was a student, you don't need to learn how to spell, you're an auto mechanic. Boy, was that wrong. Now I'm teaching, looking foolish.
I tried to catch you, man.
Anyway, I was all proud of myself there for a second. I want to laugh at the edit through that. Oh, look, I spelled that right. No, you didn't. Yep, I don't know. Whatever.
You're close.
Confirmation, talk to me about this signal, guys, right here. Not all cars have this. What do I mean by confirmation? What would tell the computer, better question, what is it looking at on this circuit right here? What will we see on this leg of the circuit? When will it be 12? The spike will be there, the 12 will be there, it changes, coil negative. Our car that we did, the Camaro with the shorted coil, right? And we had our pattern on the screen that gave us real crappy looking waveform. And when we were, this was the bad one, and the good one gave us a waveform that was kind of like that, big spike, big arc. Right? What's the computer looking at? What creates that signal? A good coil, a good feed, a good control, right? What's the computer looking at? When the computer sends this signal, what does it want to see coming back? And when does it see it? Would be a good question too. Does it see a confirmation signal when it turns the driver on?
No, when it turns it off.
It actually would, but I'm not sure the logic. It would be that's what I was going after, Shane, is when it turns it off. Because isn't that when the spike occurs?
Yeah.
I'm pretty sure that it's just looking at that part. It's charging some type of capacitor or some type of some kind of circuit is being signaled there. I don't know the design. The other thing that I don't know is there might be a component in between here that is filtering this. So it's not necessarily sending the actual signal. That actual signal is being sent in here, and that's generating its own square wave coming back this way as the confirmation. You follow?
Yeah.
But what is it looking at, or what's causing the confirmation signal? That the coil fired. This is where trouble codes come from. Okay, so one last piece. The common wires, how do we explain that? There are 3 common wires to every coil, and only the control wire is different. What I'm describing here, every coil has its own confirmation circuit. So we should have a separate wire for the confirmation. Not the case. This wire feeds into the other coils. I'll just draw them as X's. Can I feed one circuit for the ignition confirmation and tap that into every coil every coil primary, what will that look like to the computer? When this coil fires, what do I send? A signal on this wire. When this coil fires, what do I send? A signal. When this one fires, what do I send? Same circuit. So when the computer turns one coil on, like this one right here, when it turns this on, what it sees, let's go, maybe we can see red, maybe better. You see that? Okay, on there? Maybe we'll do it here. Here's what the computer will read. I don't know the timing of these two. I'll just assume that it occurs like this. How am I drawing that? The leading edge like this. What's this one? Let's say this is coil 1. What is this signal? What's this one? This is my confirmation signal. So what would coil 2 look like to the computer? Let me ask you this. Does coil number 2 have its own control wire?
Yes.
Yes. So let's say the firing order was 1, 2, 3, 4, just for argument. Coil 2 then would look like this.
Yep.
Make sense? What's coil 3 control look like? What's coil 4? Trying to line these up, having a difficult time. Does that make sense? So, can you see how we can use one single confirmation circuit that can handle all 4 coils because they're all tied together, and then the computer has logics to pick it out. Same kind of stuff we do when we sync patterns. We've been doing it the whole term. Relative compression. Look at all the cylinders, sync it with a waveform. We can figure out which one's which in a common location. Guys, this is how all the 4-pin coil over plug designs function. This is what they're doing. So what are my common wires then? My 4th wire, it's all muddy now. The 4th wire is this confirmation signal. They're all tied together. So does that make sense now on the circuit? The 2 browns are probably what? They were the heaviest gauge on those. What do you think my 2 brown wires were on the end? Probably power and ground. The control was the different colored wire, 3rd pin over. And then the confirmation wire was the other wire on the end for all the coils that were the same. Let's see if we see that on the wiring diagram. Find my coils. Thank you. You are handy to have around sometimes, Shane.
I hope so. You could highlight them.
I can. There's my coils right here, guys. Let's see if we see what we just talked about. We'll do this part, and then maybe I'll give you guys a break. You guys need a break? Yes? Okay. Brown wire, red, green, brown, green. So they all look brown to me on there. We might have a little discrepancy in color here. That's a little bit concerning. That did not look red, green to me.
No, they might have ran out of red green.
They look like 2 brown wires
It does.
on the car. Let me just take a peek real quick. That is brown, and that is brown.
And then the other one's brown green.
So welcome to, what do you talk about something that'll throw you for a loop, but now knowing and understanding circuit design, did that help?
Mm-hmm.
Can we handle that my diagram's a little off from the car?
Yes.
I don't like that. That's a red flag sometimes. That means maybe we have the wrong year of the car. When we looked up 2006, where did we get that info? From the VIN tag?
We typed the VIN into it.
Good man, good man.
You're a great man.
This red-green is not red-green. It's brown. But can you see that this same circuit is tied in, and that's all of my coils. Where does that go? Not sure yet. Unless there was a tracer on that brown. Is there a brown green on every one?
Yeah,
Okay, I see the brown green. That's there.
and the other brown ones, they're all spliced together. And then
So what wire is the red green? It's either the power or the ground, or it's that computer's confirmation signal. Let's get rid of the ink on that. The other common is the brown. Where's that wire going?
brown.
That is my main ground for those coils.
Right? That was the other brown. So the red green ones would have to be your power.
This diagram's wrong.
Awesome.
No, it's not at all. It's not awesome. According to this diagram, this circuit, this is just flat out wrong. Why would you run 2 grounds to every coil?
Just one for stuff. The transistor.
I may have misquoted the 4th wire on this. I've never seen one like this, but this is a European car, and
That is 2 grounds. That's
why would they use 2 grounds? I thought for sure.
Could one be the ground for the
Look,
driver?
I don't know why you would need 2 grounds. I mean, I know one of them's a ground for the driver, but why would you need a second ground?
For
That doesn't make sense to me. I've never seen a 4-pin design that had 2 grounds.
should we find out?
It's not important right now for this. I think the way we'll find that out would be on the car.
Yeah.
I'll let you guys break, and then we'll hook up to the car and do our checks. But I have a concern right off the bat, which is what I just told you. This is why I shouldn't use the words always and never, because what did I tell you? All 3 and 4, that's the beginning of this segment. All 3 and 4 wire coil over plug designs they work this way.
Well, it looks like you got 3 of them right.
Well, I got 3 of them right. The 4th one, the variable would be, well, at least you learned about the confirmation signals that Toyota and other manufacturers use, Nissan. But it looks like if this diagram's right, they're running 2 grounds. I'm not the engineer, I can't help you with that, but can I handle checking 2 grounds if this is the case? If this is the case, then what we're dealing with is a 3-pin coil design, no confirmation signal that we're worried about at all. What would the red-green wire be in this case? It has to be power, and then my individual violet-gray, blue-gray, red-gray, and green and brown are my control signals. Can we handle testing this if this is the way the design actually is?
Yes.
Yes. That's a little monkey wrench in our thing with 2 grounds there, but I'm not going to worry about it. Check both grounds if that's the case. I am concerned about this diagram though. I'd be lying if I wasn't, but I'm not going to park myself in front of the computer. That's not what we do. What do we need to do? Go to the car, do some checks with the scope. Let's get some direction. Okay? We'll go from there. What we're going to find, I'll spill the beans here. When we check these control signals, they aren't there. So if my control signals are not making it into this coil, are we worried about the coil wiring anymore? Let me ask the question again. Some of you guys aren't listening back there. Listen. This car does not start and has no spark. We have a discrepancy with the wiring diagram. We have a concern, a little bit of confusion. But when we test this circuit, which we're going to do after break, we check that wire and there is no on-off control from the computer. Do we care about the rest of this wiring diagram discrepancy anymore? Maybe later we will, but right now can we move on to the next step if this is the case? Yes. If I have a square wave here, do I now need to stay within this realm of what's going on with this wiring? Why are they doing it this way? The answer would be yes. Does that make sense? This is what you have to learn how to do, and it's taken me a long time to do that. When do we know when it's okay to move to the next step, or when do we stay where we are and try to figure it out by parking ourselves in front of the computer screen? Answer in this case is the result of this test, which we already know where it's going, and it's going to be away from the coils. All right, go take a break, and I'll get that reading.
Quick thought.
Wait, hold on.
About the
Hold on one sec. Hold on one
ground.
second.
Could it be some sort
Start
of
over.
about the second ground?
Quick thought.
I was just thinking.
Start with quick thought.
Quick thought. Quick thought, YouTube.
Stop with the chair.
Quick thought. I was thinking the second ground. Could it be some sort of like resistance inside before the driver in case there's like a short to ground to protect?
So you're talking about this wire going to the computer, right? Actually, instead of drawing my own, it's right here in front of us, isn't it?
Sorry, everyone. Not sorry.
The wire that Shane is talking about, let's turn these off.
Are the ones that you're not highlighting.
This one, right? You're talking about the
Nope, not the control wire.
you weren't talking about the square wave
No,
control
there's-
wire.
There's two grounds, right?
2 grounds,
I was
okay.
just saying, quick thought. Could one of them be some sort of resistance to protect the coil or driver or control?
Oh,
Could it be something like that?
yes. Yep. It's the secondary circuit. It's the secondary. That's the answer.
Okay.
I didn't want to talk about this right now.
That's okay. You don't have to. I was just
No, I need to.
Okay.
It's your fault. It's Shane's fault. You guys aren't getting a break yet. Just, I said this yesterday, and I didn't address Shane and his smart-ass comments. I should every time. But I said yesterday, 5 minutes, and I was timing because I had the video. It was like 11 minutes. So I was going to say 5 minutes again, but then I would hear Shane in that little voice that I heard. That I chopped that out because it makes you sound like you don't care.
But I do.
Right. I know it was a smart-ass comment where Shane's like, 5 minutes is up. But to them, that means you're a dick. Right? So I chopped that.
Yeah.
I was going to say 5 more minutes, I'll let you break, but
Don't do it.
I'll try. This is important. It was actually a great question, and that's exactly where this extra ground is coming from. Okay? 3-pin coil. See how quick I can do this. I always draw these, guys. I always draw these with the primary only. I never draw the secondary of a coil. There's a reason I don't draw the secondary. It just makes things muddy, muddies the water. So inside of the coil, I always draw them this way. You guys have seen this picture before, right? This goes to my ECM. There's your circuit. But where's the secondary winding? On this 3-pin coil, for a spark to occur in the secondary, it has to be a complete circuit. So one of the ways that you make a complete circuit is you tie the secondary on the feed side internally. This wraps around the primary, and then your spark comes from here. Okay? So the return path, when this thing sparks, which is actually sparking from the block and up, by the way, but when this sparks, do we have a loop through the whole system with it tied in here? Yes. If it was not tied in here on this side, would it spark? No. It would not. So this is one way that it's done. It's not how Volkswagen's doing it. The 4th wire is that. That's your second ground. It will work that way. And instead of going through the whole positive side of the system for the secondary, it will go through the plug, the gap, the coil, back to the block, and back this way. So the loop, just like a waste spark system, it would be like a waste spark coil with one of your plug wires grounded. How does a waste spark design work? A waste spark that would just be another spark would occur here. You guys understand that there's no connection to the primary on a waste spark system. Its loop is through the block and the spark plugs. What is this system using? This system is grounding one end. It's not unique to this. The reason I'm confident in this is how the GM HEI coils were designed on the old school distributor systems. They would ground the one side of the coil. That is our fourth wire. Thank you, Shane. That is the ground. That's the extra ground for that. 2 minutes, 30 seconds. He's got a timer going. That wasn't bad, was it?
No, that was cool.
Questions before we break?
No.
Okay, go take a break. Okay.